Good morning, students. Today we are going to study about lasers, the last topic of your Unit 2 of modern physics. Now, first of all, before I start the topic, I would like to tell you about the various applications where we are using the laser light. You must be well aware about the industrial use of lasers. You have seen that laser light is highly intense, coherent, and it is having a very high energy. So it is used to cut the metals and big blocks of metals too. It is also used in medical sciences where we have to damage the cancer cells, or when we are doing the endoscopy or colonography, etc. Everywhere we are using this laser light. We also use this in research purpose, like in spectroscopy. When we are doing the research, we use this laser light to excite the atoms to the higher excited states. And like this, there are enormous uses of the laser light. So we will be studying this lasers today. Now, what does this laser stands for? Laser is actually uh, laser is actually light amplification by stimulated emission of radiation. Stimulated emission of radiation. Now, what does this mean? In order to understand the meaning of this light amplification by stimulated emission of radiation, we will go to some of the diagrams and what does the meaning of this mean. So, for this, first I show you a diagram. This is an atom whose nucleus is this, and this is the first excited state of the atom. This is the second excited state of the atom, and here suppose this is the ground state where the atoms are present, and suppose there is an external photon h nu which is coming and hitting this atom. Suppose this hits this atom and brings it to the higher excited state. So how will it look like? When it goes to the higher excited state, it will come here. This kind of absorption is called stimulated absorption. Stimulated absorption. Now we have made a photon incident on this, and it is hitting this atom and taking it to the higher excited state. So this is called stimulated absorption. Now what happens? This will remain as such, or here the state is, it takes 10 to the power of minus 8 to 10 to the power of minus 12 seconds. This much time it remains in the excited state. After this, what this it can do? There are two terms called spontaneous emission. One is spontaneous emission. Here what happens? This atom will itself come to the ground state by giving out the difference of energy in the form of radiation. This is the atom. The energy of this state is E2. The energy of this state is E1. So when it jumps from higher state to this lower state, the difference of energy E2 minus E1 is equal to h nu, is given out in the form of radiation. And since no external source has been used to make the atom come to the ground state, so this kind of emission is called spontaneous emission. Now next is stimulated emission. Stimulated emission. Now what does it mean? Stimulated means we have to use a photon. We have to use an external photon. This is the atom, and we are using a photon to hit this atom When it hits this, then it comes to the ground state, and instead we get two photons. One is this photon and other, the difference of energy is given out. So we get two photons. We are getting two photons. So the light has been amplified. Instead of a single photon, I am getting two photons here. So it means the light has been amplified. This is the meaning of light amplification by stimulated emission of radiation. So the number of photons which are falling on the atoms, one photon takes out one atom, other takes out other. So if suppose 5 photons are falling on this, and then apart from those 5 photons, 5 more photons we will get which are coming out from the system. So total we will be getting 10 photons. So light has been amplified. This kind of emission is called stimulated emission because we have triggered this atom to give out this photon. So I think it's clear to you what is the meaning of stimulated absorption, spontaneous emission, and stimulated emissions. So these terms are very important when we are studying about lasers. Now, after this we will study about a three state system. This is one state. This is the ground state. This is the excited state. And apart from these two states, we take one more state which is called metastable state. Now, usually what happens at room temperature, there are many atoms, but these atoms are present in the ground state. So the population of the atoms is more in the ground state. Here the atoms are present. Now, if I want these atoms to go to the excited state, then I will have to either use a photon externally to take them to the excited state, and here they will stay for a time 10 to the power of 10 to the power of 10 to the power of minus 8 to 10 to the power of minus 12 second. And this is a metastable state where the lifetime of the atom is 10 to the power of minus 3 second. Now, what happens if I give a photon to this atom, then due to stimulated absorption, this will go to the higher excited state. And when the atom goes to the higher excited state, it may come back to the ground state either spontaneously, or sometimes there are some non-radiative transitions. Non-radiative transitions. Non-radiative transition means light will not be given out, but some processes like internal conversion, or there is one more process called intersystem crossing. These two processes can proceed, and without emitting any radiation, the atoms can relax to the metastable state. If they come back to this state within this time, then here they will stay for a very long time, 10 to the power of minus 3 second. And suppose it comes here and one photon comes to hit this, then I will get two photons here. I will get coherent light here. So now what my aim is, actually if I have only one atom here and only one atom is hitted and it comes out with two photons, then the light will be not of very much use for us, because it will not be very high beam, it will not be very intense, and its amplitude will also be not too much. So what we have to do, we want more number of atoms in this state, and more number of atoms in this state is possible if more number of atoms are present in the excited state. So what we do, we use source of light here to hit these atoms, and these atoms will go to the excited state, and more number of atoms will be present in the excited state. So this phenomena by which, this process by which the number of atoms is made more in the excited state than in the ground state. Suppose the number of atom in the ground state is N1 and the number of atom in the ground state is N2. If somehow we can make N2 greater than N1, if somehow we can make N2 greater than N1, greater than N1, then this is called population inversion. This is called population inversion. Means we have inverted the population. The number of atoms is made more in the excited state than in the ground state. So in order to achieve this population inversion, what we do? We use many methods, but one of the process is called optical pumping. One of the processes is called optical pumping. So what happens in optical pumping? Inside the tube where the lasing action is done, inside the tube we have a source of light. So by means of that light, we go on giving the radiations continuously. When we are giving the radiations continuously, then these atoms are excited and taken to the higher excited state and the population inversion takes place. And out of those atoms which are present in the excited state, some of them may come spontaneously to the ground state. Now, those atoms which are coming spontaneously will not be in the same direction, will not have they may have same energy, but they will not be coherent and the directions may also be different. But those excited atoms which relax non-radiatively and come to the metastable state. So, if suppose two atoms are coming this time, later on more atoms are excited, some more come here, because here the stay of the atoms is longer. So if the stay of the atoms is longer, they will stay here for a longer time. And because inside the tube continuous light is being given, so those photons, they will fall on these atoms and a very high coherent beam in the form of a laser will come out like this. So this is called the lasing action. This is called a three-stage laser. This is called a three-stage laser. So generally in a laser, we have four-stage lasers also, but generally in a three-stage laser, we have three stages, which I have already explained you, and there is continuous source of light inside it, which goes on exciting the ground state atoms to the excited state. From here, they may come back spontaneously to the ground state, or they may go to the metastable state. From the metastable state, after this much time, the number of atoms which are present here, they will give out laser light of same frequency and come back to the ground state. So this is the lasing action. The example of three-stage lasers are, we have ruby laser, we have helium neon laser, helium neon laser. This is helium neon laser. So later on we will see how these lasers work and what is the material which is used inside it. So we have studied about what is the lasing action and how to achieve a laser light. Now I would like to show you this with the help of diagram. Suppose I have this light, I have this light, I have this light. In the second case, I have this light. And in the third case, I have this light. So what are the differences between these three lights? This is ordinary light. This is ordinary light. Why is it ordinary? Because see, the wavelengths of all the waves are different. And here the wavelengths are same, but they are not in same phase. So this is called a monochromatic light. This is called a monochromatic light. And the third one is, here the wavelength is also same and they all are in the same phase. So this is monochromatic as well as as well as coherent. So this light is called the laser light. So what are the properties of laser light in brief? I would like to tell you. First thing is it is monochromatic. First is it is monochromatic light. Second is it is highly coherent. Third is its intensity is very high. And fourth is uh, intensity is very high, it is monochromatic, it is highly coherent, and its divergence is very small. You must have seen the small toy lasers. You must have seen when you throw the light on the wall, you in a dark room you will see only a spot because the divergence is very small. So these are the characteristics of the laser light. So rest we will study in the next class. So thank you and have a nice day.